Alright, here we are with part 2 of the video talking about solving word problems using systems of equations. Now, as we read number 3, little Billy has 111 coins, and they're made up of having quarters and nickels. It says he has a total of $10.35, and we want to know how many of each coin he has. Okay, it's asking how many of each kind of coin he has. So that tells you exactly what you're looking for and how you should define your variables. Your variables should represent the number of quarters and the number of nickels that little Billy has. Now we could use X and Y, but I think it would make much more sense to use Q and N. Now if you would prefer, you can use capital Q. So let Q equal what? We don't want to say just quarters, we want to be more specific. Let Q equal the number of quarters. And then, of course, let's let N equal the number of nickels. That way, when we solve our system and we have Q and N, we know that Q is the number of quarters, N is the number of nickels. If you use X and Y, who knows what they represent unless you have clearly defined them at the beginning. Your X may be different from somebody else's X, but I'm pretty sure that if you see someone using Q in this problem, they're always going to be representing the number of quarters, so it takes away some of that ambiguity. Now, as we saw with problem number 2 in the other video, most of the time we have one equation that deals with just counting. So, looking at the information here, and seeing how we have our variables defined, can you come up with an equation that deals with just counting, I guess, the number of coins? Well, it says here he has 111 total coins, and they're all made up of quarters and nickels. So if I take the number of quarters and the number of nickels, how many total coins do I have? I have 111 total coins, and this deals with just counting. Well, we also said that the other equation should deal with the value that goes along with each of these. Well, how much is a quarter worth? Well, a quarter is worth a quarter. So if we make that a decimal, we're going to need to say 0.25 times Q. Now when I say 0.25, keep in mind that I'm keeping this in terms of dollars. Why dollars? Well, I was working with dollars to begin with. So 0.25Q plus the value of a nickel is going to be 5 cents. But we need to make sure that we remember that's 0.05. If you do 0.5 itself, 0.5 is a half dollar, and that's really going to throw things off. So again, this is in terms of dollars, and it equals $10.35. So this is the equation that deals with the value of these coins. The total value of the coins is $10.35, 5 cents for every nickel, 25 cents for every quarter. And the total number of coins is going to be 111. Now, if I were going to be solving this one, I might use the substitution method, because this first equation would be very easy to solve for either Q or to solve for N. Granted, you could also use the elimination method, and you can multiply this top equation by either negative 0.25 or negative 0.05. Really, pick your poison. It's all going to work out well. Now let's look at this fourth word problem here. What we have here is another fantastic story problem. Erica buys 5 hamburgers and 3 orders of fries for her family, and her total is $21.50. Jeremy buys 3 hamburgers and 4 orders of fries just for himself, and his total is $16.75. The question here is, how much do the individual items cost? Well, what are we looking for? We're looking for how much each item costs And the items that we are concerning ourselves with are hamburgers and orders of fries. Well, we could use x and y, but again, let's make these variables make more sense for the problem. So let's let h equal what? Hamburgers? Not quite. What is it about the hamburgers? Is it the number of hamburgers? Well, no, because we know that Erica has 5 and Jeremy bought 3 hamburgers. What we're specifically looking for is the cost of that item. So let h equal the cost of 1 hamburger. And if we let h be the cost of 1 hamburger, maybe we should let the variable f equal the cost of 1 order of fries. That way, when we have the h and the f all in our system of equations, it's going to make sense that h is for hamburgers, or the cost of a hamburger, and f is for the cost of fries. Now, unlike the problem that we just got done working or setting up, we don't have a counting or a value equation. Instead, we're going to have 2 different people's orders. So let's look at it this way. For this first equation, let's see if we can represent Erica's order. Well, Erica bought 5 hamburgers, and she also bought 3 orders of French fries, and her total came out to be $21.50. Since we're looking for the cost of each of the items, we can take the quantity times the cost plus the quantity times the cost to get my total cost for those items, $21.50. And now let's look and see about Jeremy's purchase. He bought 3 hamburgers, and he also bought 4 orders of fries, and his total came out to be $16.75. So, nothing deals with counting. It's all about the hidden values that are in here. So, the best way to solve this system of equations is by doing what? Substitution? Really? No, come on now. If you do substitution, you're going to have fractions running around. And we know what happens when you have fractions. You leave it blank. Don't do that, though. Instead, let's use the elimination method. It may not be pretty, but it's going to be the best way for you to solve this. So, try that and see what you come up with.